Hello, this is a short series of presentations to assist paraglider and hang glider pilots who are studying for their BHPA pilot rating exams. This series is on meteorology. These are the areas of meteorology that the pilot syllabus mentions. It's a huge and fascinating subject and one that you can always learn more about. Let's start with pressure systems and see how the Earth's winds move around them. To understand where winds come from, we need to appreciate the concept of atmospheric pressure. Atmospheric pressure is caused by the gravitational attraction of the planet on the mass of atmospheric gases above the surface. These forces, which press down on the Earth's surface, are then modified by planetary rotation and local effects such as temperature and water saturation, causing density variations of the air. It is important to remember the figure defined as the standard atmospheric pressure, 1013.25 millibars. In many countries, the term hectopascal is now used rather than the millibar. This beautiful animation illustrates how the air typically moves around our planet. The little spots of yellow are rainfall. It's quite mesmerizing. The duration of the total animation is equivalent to around 2 weeks in real time. And as you watch it, patterns become visible. In the UK, most weather systems form out in the Atlantic along a frontal boundary between the cold Arctic air mass and the warmer tropical maritime air to the south. We will talk about that boundary and the fronts and the weather they bring in another section of this series. Because the Earth rotates on its axis, causing night to follow day, our circulating air is deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. This deflection is called the Coriolis effect. Let's talk about high pressure. A high pressure system is also known as an anticyclone, and it occurs when the weather is dominated by what's known as stable conditions. Conditions are said to be stable when the atmosphere has a tendency to resist vertical air movement. In these circumstances, changes in temperature, pressure, and wind happen gradually with height. This leads to calm, predictable weather conditions. Under an anticyclone, air is descending from the higher atmosphere, forming an area of higher pressure at the surface of the Earth. Because of these stable conditions, cloud formation is inhibited, so the weather is usually settled with only small amounts of cloud cover. In the northern hemisphere, winds blow in a clockwise direction around an anticyclone. Perhaps one rather off-center way to remember this is that in an anticyclone, the wind direction is not anti-clockwise, it's clockwise. On this synoptic chart, the anticyclone or high pressure area lies to the bottom left of the chart in the center of the Atlantic. Winds will flow in a clockwise direction around the high pressure feature and will bring northwesterly winds to the British Isles. In summer, periods of high pressure bring clear blue skies and light winds. Strong convection may lead to thunderstorms, and hazy inversions can develop too. More of those features in a later section. Cloudless skies in winter mean colder conditions. If the air is still, strong ground inversions may develop, bringing fog and frost. Isobars are the plane lines curving across a weather map. They connect points with the same air pressure. Some isobars have numbers on them showing this value in hectopascals or millibars. Isobars also indicate the flow of air around the weather systems. The spacing between the isobars is an indication of the wind strength in an area. Isobars are normally widely spaced around an anticyclone, so winds are often quite light. They're usually closer together surrounding areas of low pressure and the tighter spaces indicate stronger winds. To understand the likely wind direction from a synoptic chart, it is important to appreciate the way that winds flow around the pressure systems and the fact that on the surface they flow into a low pressure slightly and out of a high pressure system very slightly. From an aviation perspective, you should also be aware that the wind will veer as you ascend by several degrees. This means that if it is due westerly at launch, it will have a slightly northerly component at cloud base. A low pressure system, or depression, occurs when the weather is dominated by unstable conditions. Under a depression, air is rising, forming an area of lower air pressure at the surface. This rising air cools with height and then condenses, forming clouds. So in low pressure conditions, the weather is often cloudy and the clouds often drop moisture as rain. In the northern hemisphere, winds blow in an anti-clockwise direction around a low pressure system or depression. Isobars are normally closely spaced, leading to stronger winds. Depressions can be identified on weather charts as an area of closely spaced isobars, often in a roughly circular shape, where the pressure is lower than surrounding areas. They are usually accompanied by fronts. On this synoptic chart, we can see that there is some moderate westerly winds over the UK and that a warm front has recently passed through. Another warm front is on its way. In meteorology, there's something called Buys-Ballott's law. It's named after a Dutch meteorologist who first published the idea in 1857. The law states that if a person stands with their back to the wind, then the atmospheric pressure will be low to the left and high to the right. Remember, low to the left, and the rest then follows. On this synoptic chart, which shows a deep depression in the mid-Atlantic and a high pressure system over the eastern Baltic region, we can see that the winds will be generally southerly to the west of the British Isles. When areas of warm and cold air meet, the warm air rises up and over the more dense colder air. The colder air mass forces its way under the warm air, which is pushed upwards. As the air rises, its pressure falls and we get an area of low pressure conditions. This is how a low pressure system is formed. On weather charts and forecasts, you see the fronts that are associated with the depression marked in this way. The red line with half circles is the warm front, while the blue line with triangles is the cold front. On the map, these lines are marking the location where the temperature and pressure of the air is changing. That concludes the section on pressure, the Earth's rotation, and the movement of air masses. In the next section, we'll look at frontal systems in more detail.